Yeah, welcome back. I hope I'm audible as well as my screen is visible. I am also visible to all. So, welcome to this particular training program on data mining using Weka. Today is our second day. So, in today's session, we can see these contents as per the syllabus. Okay, so the syllabus of the second day is this one. You can see some data cleaning techniques, data transformation techniques, handling missing values, and then the information can be used for cleaning the data. Okay, so data normalization, then the data standardization, along with some feature selection methods, we will see practically. As discussed in the last session, hope so you have installed the software. So it is one of the desktop-based software. So computers or laptops are required. One of the participant has asked the question in last session that can we like add install the Weka in a mobile phone? So that is not possible. Fine. So Weka software will not be installed in the computers, sorry, in the mobile phone. So it is particularly based on the, you can say the desktop based, computer based software, right? So see, uh, here in this session, I will just give the demonstration about the Weka for cleaning the data, like what type of filtering methods we can apply, then how can we normalize the data, how can we convert that data into suitable format which is required for classification purposes. So in a classification we will try to build model. So in model building, this converted data is needed. Okay, so attribute selection is one of the important topic of today's session. Means which particular attribute or which particular feature I will choose for further analysis. Then data exploration, its visualization, along with some methods we'll see in this session. Okay, so basically data cleaning is one of the important part of a data mining. In last session we have seen one diagram there. We have seen like how can we create, convert the data. So whatever input data is there, right, that input data we can just like convert into the suitable format using some pre-processing steps. So this is our the topic, data pre-processing in the Weka. Data pre-processing in the sense ki I am having data, it is not converted into any format. In the data, let's consider some values are not there, or some similar values are there, or some columns are missing, some rows are missing, or some duplicate values are there, null values are there, or some unwanted information is present in the data. So whenever such type of information is present, so whatever models we are trying to develop, machine learning models or the artificial intelligence based models, deep learning models, whatever models we are trying to build on the data, so will not give the good performance. Okay, the meaning is that raw data must be converted into the model suitable format. So then the machine learning model or the deep learning model will give us the desired output. Okay, so whatever output we are looking for, that output can be gained through the this particular pre-processing technique. Okay, so pre-processing is, that is why important. means the data must be clean and transfer into the suitable format. So in this case, whatever missing values are there, abnormal values are there, right? Raw values are there that can be converted and mm, it can be used for further analysis. And then attribute selection means the feature selection. So here are some algorithms for selecting the features. So we'll see. And now just I'm sharing my complete screen for visualizing the content. Okay, so here I'm just sharing my complete screen. Hope so it is visible, right? So in this case, we'll try to use some information. You can see the install software. Which one is the install software? The data mining, right? Veka. That is the software name. So already we have installed it. Just search in your computer. Fine. You will get somewhere the name of Veka 3.8.6. This is the latest version, right? So this latest version, we can like explore. So this new window will open as whenever we try to open this software. Fine. And as discussed in the last session, you can see some of the properties, some of the applications are there of using the Veka tool. So here our target is to use Explorer. Fine. So that is why I'm just clicking on this Explorer button. And now see the new window is open. I'm just trying to minimize this window. Fine. So this minimize window uh, gives you the information regarding the pre-processing, then the classification, clustering, attribute selection, visualization of the data, and the filtering methods. Okay. So today's topic is that like normalizing the information, converting information, transforming the information into the suitable format. So in the first tab only, in the first menu only, Veka is providing this information. Okay. So pre-processing under this folder, under this particular menu, you can see four different buttons are there. Those buttons can be used for uh, getting the data sets to upload the data. We can use any one of the source. Okay. So open file means whatever files are there in our system, whether those are by default given files or you can say the data or downloaded files. Both the types of files are there in our system. So we'll try to open those files. You can see the data. And whenever we move the cursor on this particular first button, you can see here open a set of instances from a file. Set of instances means the records, okay, the values present in the file. So some formats are given by the Veka for uploading the data sets. Standard one of the format is that like a .csv. So that is the standard format because in that .csv format, .csv file, we can have the rows and columns. Okay, similar like a Excel, a Microsoft Excel. So in Excel, we are having some rows, some column, right? So in that case, .csv file is also providing rows and columns. Okay, .csv is nothing but the comma separated value. CSV, comma separated value. Okay, so we will try to open the set of instances. Now here instances are nothing but the rows, whatever present in the file. Which file? Here today we will upload the .csv file. Okay, because other formats is a little bit complicated to analyze. That is also possible, but as a time limit, we will try to work with the .csv file. .csv, as mentioned, it is a comma separated value files. Okay, and in that file also some columns are there like a Microsoft Excel, and some rows are there. Rows means instances or records, and column means attributes or feature. Fine. Second button, open through the URL. Means here directly you can give the link. I have just click on that. You can see enter the source of URL. So whatever data you want to fetch from the websites, online website. So here you can give the address of that particular website, and you can just load that file, okay, or that data. Directly click on OK. But as discussed now, I have already downloaded the files, and some by default files are also there in our system. So that is why we will not use this option for this moment. Maybe if we will get more time, we will use there. Then open database, you can click on this, and here also you can give the URL, some query we can run, and then we can open the SQL files. Okay, structured query language. So that particular data also we can load here. And last one, artificial intelligence methods are used to create the data. So here artificially we can generate our data. Fine. So that is the advanced topic for generating the data. So that is not our target now. And as discussed, see, other options are not visible now. Why? Because we have not uploaded the data. So first of all, we will upload the data. So how to upload? Just click on open file. So this option will try to upload data from our local disk. Fine. So by default, data sets are there as discussed, even though the files are also there which are downloaded. So that will also I will show you like how can we add that information. But right now, firstly, we will upload the by default data which is provided by the Weka. So here double click on this C drive because of Weka software we have installed into the C drive. Fine. So just try to click on the particular icon, not on the name. Fine. So parallelly, you may do this particular task. So whenever I click on this one and open, you can see it is not loading the file because cannot determine file loader automatically. So please choose the file. So that is why click on that icon. Okay, click OK. Now again I will try to open the file. See here from the like C drive, just double click on the icon. Okay, here the install program files will be obtained. Again, one program file is there, correct? So Weka software is installed in a program files. Again, click on icon, not a click on the particular name program files. Double click on a program files. After double clicking on the program files, we can have the install softwares. Too many softwares are there in the system, but this is our target, Weka 3.8.6. So in this case, we can just have the information, right? You can see now. Again, I am double clicking on this icon instead of this one. Instead of the name, I am clicking on this one. Fine. So here again, four folders are present. So four folders will give the different information. So our main target is to use the data. Again, double click on the icon, and now see here some sample data sets are given. Okay, so sample data sets. So today, for example, we will see this weather sample database. Okay, and click open now. So see weather dot nominal and weather dot numeric. Both the files are there. Okay. So either any one of the file we can choose. But today we will pre-process the data. We will renovate the data. So that is why nominal information, nominal weather data I am selecting. Why nominal? Because as mentioned that in the file, in that file, some of the information is present. Okay, some of the information in the form of columns and in the form of rows, right? So here in this particular nominal format, we will get some information which is not suitable for the numbers. So that will be the nominal format. So we will convert that information. Now click on open button and see the data is open. Fine. I have not applied any filter method. Just now we have loaded the data into the Weka software, and this is the simple normal data. Even though we can do the image processing in the Weka also, but for that purpose some plugins we have to install. That is the advanced story. So here only normal data we have uploaded for this moment, and you can see some of the information is displayed here. Whenever we upload the data file, some of the information is uploaded here. You can see which one is that information. Current relation is the weather.symbolic. So this is the name of that file. Okay, how many instances are there? 14 instances. What do you mean by instance? Instances are nothing but the records or the number of rows available present in that particular file. Okay, so in this particular file, how many rows are there? 14 rows are there. So that is nothing but the instances. 14 type of records are present in the file. Now here one more information is there, that is attribute. Okay, attributes you can see here. I hope it is clearly visible. Attribute, here you can see 5 attributes are there. Attributes are nothing but the properties of the data, or you can say the features of the data, or you can say the characteristics of the data. So those terms are same. In a Weka, for features, characteristics, we are calling attribute. Okay, and sum of weights, 14. So which is equivalent to the instances. Means the number of instances equivalent to the sum of weights are same. 14 instances are there. Sum of weights are also 14. Fine. So attributes, you can see as mentioned here, attributes are 5. Where to check whether my attributes are nothing but the columns, whatever present in the data, whatever present in that file. Instances are nothing but the rows, and attributes are nothing but the columns if you are using the .csv file or this ARI file. Okay, 5 attributes are there, means 5 columns are there in the data, and the column names are, you can see here. First column name is Outlook. Second column name is temperature. Third column name is humidity, windy, and play. So these 5 columns are there, and according to the 5 attributes, we can generate the model. Okay, so some of the attributes we can select, and then we can give to the machine learning algorithm, that is classification algorithm, and then we can check our output of a classification, whether I should play or not. Okay, so here selected attributes are like which one is the selected attribute? Outlook is the selected attribute, right? So see, name of the selected attribute is Outlook. Type is a nominal, because there we have selected the nominal. Distinct values are 3. You can see in that particular column. Which column? Outlook column. 3 informations are there. 3 different informations are there, like a sunny, overcast, and rainy. And missing values, there is no missing value. All the values are present in the data. Unique values, 0 unique values are there. All the different values are there. Fine. So that is the information about this first attribute. Now second one is the temperature. Temperature, you can see the nominal. Type of temperature is a nominal. Humidity is also nominal. windy is also nominal, and play is also nominal. Why so? Because there we have selected the nominal file. Fine. So I will try to open the numeric file now. Now see, what is the change? Change with the data type, change with the attribute name. So first the Outlook is having the same name, that is a nominal, but how many distant values are there? Three values are there. Nominal means the names sunny, overcast, rainy, right? And as mentioned here, total number of weights are 14, or total number of rows instances are 14. So in a 14, 5 rows are there which are related to the sunny, then 4 are related to the overcast, and the remaining 5 are related to the rainy. So total 14 instances are there for this particular column. Column in the sense particular attribute, that is Outlook. Now I am selecting for this temperature. Now see the type. Type is a numeric, right? So this you can see the type is a numeric. Unique values are 10, distant values are 12, means 12 different values are there related to temperature. Can be minus temperature, can be minus 1 to plus 1, then or this is one of the example. I can be such type of values may be there in the data. Missing values, nothing missing values are there. All values are present in the data, but the value type, attribute type is a numeric. In the sense numeric, in the sense key minimum values are 64. You can see through this graph also. Here this graph I have selected. When we select particular attribute, automatically this graph will also change. I am selecting Outlook. Now see the graph is also changed. I am selecting the other format. Graph is changed. We were discussing about temperature. Now see minimum values for temperature are 64 and maximum values are 85. Here is also you can see, here also you can see the number. So meaning mean is 73.57 and standard deviation is 6.572. Okay, so that is the numerical value we are having with the attribute second. Attribute third, that is humidity. Okay, so this humidity is saying that again 10 different distant are there, and minimum values are 65, maximum are 96, mean is a 81.64, and standard deviation is a 10. Unique values are 7, means 50% values are unique in this particular column. Hope so you are getting my point, right? And missing values are null. There is no missing value. All values are present. Missing values are 0, but unique values are 7. Means remaining 7, remaining 3 values. Total 10 values are there, right? And unique values are 7. Means remaining 3 values are having some error or some problems. Might be, right? Now I'm selecting the next attribute, YD, and this the type of YD is a nominal. So either true or false. Only two distinct are there, and unique values are 0. Missing values are also 0. Only two are there, and you can see the count 8 plus 6. How many values are there? 14 values are there. And here also the type is a nominal. Yes, and 9. So total is a 14. Okay, now what exactly data is saying that if outlook of the environment is sunny, so then I can play or I will not play. So yes or no, shall I play the game, whatever game if you want to play. So based on this data, we can find out the answer. Shall I play or not? So this is the target. What we have to classify in the particular environment, can I go for playing the game or not? Okay, so only two classes we are having here, that is yes or no. Okay, two classes are there, like first class is saying yes and no class are saying second class is a no, that is having 5 values. But the data is known to us now, right? So if data is known, if we have the knowledge about the data, I mean the developer who is trying to analyze the data is having the knowledge about the data. So in this case, blindly apply the supervised algorithms. Okay, so supervised, unsupervised machine learning algorithms are there, which are used for getting the output of a classification. Yes or no? Classification, right? So first class is saying yes, second class is saying no, likewise. Fine. So if outlook values, if sunny values are there, five sunny values are there, then I can go. You can see here in the diagram also, sunny values are 5. Okay, that means you can go. Rainy values, overcast values 4. That means we can go. That the blue color is saying that you can go for playing the game, whatever you are looking for, right? Here also rainy having 5, sunny here also 5, and rainy here also 5. Okay, so graph is saying the same thing whatever displayed here. Okay, if the values are near to 9, means if the temperature is a little bit okay, then overcast is okay, then the match or the game can be played. So likewise we can get the output. Even though we can see for the temperature, minimum temperature is a 64, maximum temperature is a 85. Okay, so if this is the case, we can go here. So values are saying that, 6 values are saying that go for playing, and 8 values are saying don't go for it. So 8 and 6. So that means values, highest values are more. Which one? 8 values are more. So they are saying that don't go because temperature is high. So likewise, based on this information, we can try to find out the solution. Humidity, whether the temperature, whether the environment is humid or not, or what type of condition is there. According to that, we can just see here some values again. Total 14 instances are there, 7 are saying you can go, and again remaining 7 are saying you can not go. Means unique values are 50% only. So 50% are saying that okay, and remaining 50% are saying uh, don't go. Likewise, windy again here. See, blue means you can go. 6 values are there, and here the next class false values are 8. Don't go. Now, based on this particular information, we are trying to upload the, trying to get the solution. What type of solution will require? We will require the output, whether I should go or not. Okay, where to go for playing the game based on environmental conditions, outlook conditions, based on temperature condition, based on humidity condition, based on windy conditions. So these 4 parameters are there. Based on all parameters, finally we can find out the solution in the form of yes or no. So that is the output of a classification. So based on this information, here we can apply any model, and automatically we can get our solution through those models. Fine. This is the first step now. And you can say, you can see here some information is in the form of nominal. Data type is a nominal. Second data type is a numeric, that is a temperature and humidity. Third is also numeric. So some data is available in the form of nominal, and some data is there in the form of a numeric. So in this case, filtering methods are needed to convert the data into same format, right? Total, how many attributes are there? 5 attributes are there, and last attribute is also having the values in the form of nominals. Fine. So the point is that here the data is having different values. Some values are numerical, some values are nominal. So in this case, we have to convert the values into same format. Getting my point? So same format values. In that case only we can find out our solution. So here filtering methods we can apply on the data. Just click on choose filtering method. Okay, and then accordingly we can get our output. So click on choose option. Here are some filtering options by default given by the Veka. So that is the beauty of data. Why data is important and why pre-processing is important. So here, as mentioned that through the pre-processing, we can convert the data into the same format. If missing values are there, here in this case, no missing value is there right now. So in all cases, well, all values are present. You can see missing values are 0. But in some cases, some missing values may be there. So, so we can directly apply the filtering option through this particular filter methods, and then we can get our output. Okay, and if I want to apply any one of the algorithm here, that is filtering algorithm, you can see supervised and unsupervised algorithms are there. So here we will select the algorithm from unsupervised under the attribute menu. Too many algorithms are there, like see, add cluster algorithm is there, add expression is there. So this filter creates new attribute by applying the mathematical expression. Okay, so we can generate the mathematical expression in Veka also, and then we can add that filter on that expression, and we can get our output. We can add the ID also. Whatever ID is required for the data, we can add that one. Then we can manually add some noises also, add some use fields also, and too many information we can do here. Okay, and see, too many algorithms are there. That is why Vega is important. Okay, so we don't know about programming, for example. So in that case, directly select the particular filter method, like our mobile phones filter options, right? So like if a photo or image captured by mobile phone is a little bit blurred, then in that case we are applying the filtering options, right? So filtering options here also we can directly apply, and then we can convert our information. Image, blurred image we can convert through the mobile's filter, right? So here also the noised information can also be converted into the suitable format, right? So here that is why too many algorithms are there. Normalization. So as mentioned that normalize all numeric values in the given data set. All values in the form of 0 and 1 we can normalize. Numeric cleaner, so numeric to binary conversion, so that can also be done. So whatever numeric values are there, but our data is having some nominal values and some numeric values. So in that case, here we can apply the option that is a discrete option. Yeah, here is the option I have selected on the discrete option. You can see here instances also having, we can remove some randomized information, we can duplicate, we can remove the duplicates, but in the data there is no duplicate value. We can remove the folds, we can remove the frequent values, means similar values we can remove, misclassified values we can remove, ranges we can remove. But in our data there is no missing value and other values, so there that is why this particular option is not applicable right now. And even though all type of algorithms are there, you can see a standardized algorithm is there, swap values algorithm, time series delta, translate, and many more algorithms are there. As per the requirement of algorithm, we can select anyone. Normalize, yeah, data is normalized, but having the different format. How can we get that information? Through this particular panel. Okay, so here now I am clicking on discrete, and whenever we click on discrete, you can see in this particular URL, you can see the information about that method. Okay, now just we have selected the algorithm of a filtering. Okay, that algorithm, discretization algorithm we have selected, and now the second task. See again, My first attribute is nominal, second attribute is also numeric. So I have to convert into the suitable same format. So that is why we have applied here the discrete. Now just we have selected that particular algorithm. Now here just click and you will get the GUI for generic editor. Okay, so in this case, filters, whatever we are trying to apply, that is discretized. So that range will be converted into nominal attributes. Just only one change we have to do. One change, by default settings are there. Don't change the setting because the data does not require the settings. So here only one information is needed. That is the use equal frequency and click on it true. Okay, what we have to do, only this option we have to change, use equal frequency and click on OK. Now see again, there is no change in the type of data, so the data is same. Why? Because this button, this apply button, we have not selected it. So click on apply now, and now we can check whenever we apply this one, click on the second one. Yeah, see the second one is a change now. Previously, the temperature attribute was in the numeric format. Now it is there in the nominal format. And see the labels. 10 labels are there. Hai na? 10 distant values are there. You can see here. 1, 9, 1 to 10. And unique values are 6. Okay. So that is the use of filtering method. Just you can see here for the humidity. Here also 10 distances were there, unique values were 7, and the type of was numeric. So if data is having numeric values, then in that case only discrete algorithm for filtering purposes we can apply, so that will convert the numbers into the nominal format. Numeric data type will be converted into the nominal format, okay, through the discrete method. And here some again algorithms are there, for example nominal to binary. So that is also possible, but here values are not binary, more values are present. That is why this is not applicable. Cleaner, normalizer, normal data is already normalized because that is the normal simple data. Okay, so here you can see now the windy information, it was already the nominal type, so it has not changed, but the data is changed with respect to this two. Fine. And accordingly you can see this particular graphs are also changed for this temperature. Previously a graph was showing the different information, and now the graph is saying the different information as per the 10 distant value. Okay, you can count here 1 2 3 4 5 6 7 8 9 10. So whatever values are there, so all the labels along with values are displayed here. Now if I want to visualize all the graphs at a single click, just click on this one, all the graphs for 5 attributes. How many attributes were there? 5 attributes were there. So for all graphs, for all 5 attributes, we can generate the graphs. See, for Outlook, this was our first attribute. Second was the temperature. Third was a humidity. The fourth was windy and play. So we can display that, and we can use for visualizing the information. Visualization of information is also one of the major topic of today's session. Visualizing the information, so this numerical values we can show through the graph, and then we can put into paper or reports, whatever you are looking for, right? But there is one limitation uh, of Veka. Some limited visualization we can display here, and some graphical format is little bit low. I mean the quality of graphics is little bit low. So that is why this is not suitable for graphical purposes. Okay, if you want to generate more graphs, more quality graphs, so we can just plug in Python with a Veka and then we can do it. Okay, so that facility is also there for visualizing the content, or even though Python directly we can prefer for visualizing the content only, and rest of the things we can do here. Fine. So this is the particular task for the filtering purpose. Now we will apply one more filter. For example, here uh, we will try to load one more data. Let's consider here diabetic data or iris data. Iris data again, see total 150 rows are there in this data, and attributes are also 5, and the type of all attributes are a numeric instead of class. Total 3 classes are there, and based on these different numeric values we can find out the classes. So here 3 classes are there. In the earlier data 2 classes were there, yes or no? Here 3 classes like iris, sedosa, versicolor or virginica. So these classes types are there and their values like 50 total 150 values are there, and each class consisting 50 or you can say the equal values. Fine. So here I will apply some algorithm. For example, like what is the type? It is nominal, then the numerical, numeric. All the numeric values are there. So here we will try to apply numeric to nominal. Okay, because all values are there in the form of numerics. And now I want to convert that value into nominal format. So just select true, click OK, apply. It is not applicable, I think, not applied. False, OK, apply. Yeah. So I made one mistake there while clicking on that. Here I have selected inward selection. So keep as it is. No need to change that. And now you can see the data is changed into the form of nominals. It was in the form of numeric values, and now it is in the form of nominal. Okay. So that is the case of filtering. One more method we will try to use here. Replace missing values. For example, ignore class, keep as it is, apply. So there were no missing values. You can see no missing values. If missing values are there, it can be replaced automatically. Okay, so all this type of pre-processing we can do here through this filter option. Even though supervised options also we can select, but having some other information in this case. So that is why unsupervised will be used here. Okay, so next one is that the today's session is like a data normalization. So we have just seen one method here, normalizing the data. So where is that information? Normalization, you can see here. Yeah, normalization. Keep as it is all settings. Apply. Data is normalized. Now see the information is changed. Label information is changed. Data is normalized. You can see normalized in the sense कि some values were different. Okay, one value was for example 0 and another value was for example 50. So the difference between 0 and 50 is too much, right? Through the normalization, we can just correct the similar values. So we can convert those. Now see here, CPL length 4 point something to 7.9 is the range. Means the values are nearer with to each other. Okay, and here see for this label from 2 to 4. Again the values are near to each other. Length 1 to 69. Then 0.1 to 2.5. So the values we can likewise normalize, and then we can use it for the further analysis. Okay, so on this, if you have any question, you can uh, ask it now. So the session is open for question answering. You can ask the question now if you have. Kevin is saying that can we please repeat the changes we need to make. So Kevin, as per the data, changes can be made. Okay, so for example here, my data is numeric. Okay, you can use any data. This is by default data. Uh, or we can take the breast cancer data, open it. Okay, and in this particular data, 286 rows are there, and 10 attributes are there, means 10 columns are there, and the type is a nominal, 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 but age must be numeric, right? According to age values should be numeric values, and the classes are again two, no recurrences and recurrences. So whatever filter you want to apply, just click on that filter as per the requirement of data. So here our data is having nominal values. So in that case, we can convert data into, for example, in the numeric value. So here is the option numeric to nominal. Okay, and click apply. So the data values will be changed accordingly. Or if you want to normalize the data, now see the information, the labels, 30, 40, size of tumor, then the age in between 10 to 100, right? So we'll apply the normalization in this case, for example. So there is a little bit change in the data. So already data was normalized. Okay. So likewise apply. Fine. As per the target, as per the data requirement, we can apply any one of the filter. Okay. So if your data is a numeric, or and you want to get the output in the form of nominal value, so you can apply numeric to nominal. If your data is having two different platforms, two different formats, so in that case, discrete option we can use, right? So that discrete option, and here only we need to change the true value, click OK and apply it. So all the formats will be same when we apply the discrete. So every algorithm, whatever given here, are having their own advantages, disadvantages. So which algorithm is suitable for our data and what is our output? What type of output we want? So according to that output and according to the data, the methods can be changed. Okay. Other question? Yeah. Shruti Khandelwal is saying that Veka on my system does not have the files that you are working on where I can download them from them. Okay, Shruti, just do one thing. Open your my computer C drive. Under the C drive, you will get one folder that is program files. Okay, just click on the icons. What type of icons? So just now I have shown that. Click open file. So let's consider this is the particular case. The left side icon is there of a drive C and all, for all drives. So double click on the icon. So it will open the folders. Again, double click on the icon of folders. In program files, our data are present. Click on that. Again, under the data, wake up folder, just you have to search for it. Double click on that. Data folder, double click on that, and here you will get the data sets. Okay. So in a C drive, program files, Weka, data, and there you will get the required data. So this is the by default data. I will show you the external data which I have downloaded, and the link also I will share with you, and I will show you from which website we need to download the data. Next one is that Darpan is saying that is there a need to plug in Weka with Python for analysis of healthcare data like scans and X-rays? If you are working with the image processing, so then uh, we can combine Python and Weka. Okay, so in that case we can do that. Even though if you are having the images and if you want to load through the Weka, so just download the image processing plugin. Search in the Google image processing plugin for Weka. So that plugin you have to install in your system. So it will be faced with the Weka, and then you can use the images like X-ray images or CT scans images, and then we can analyze that information. Fine. Again, Darpan is saying that how to decide which algorithm is better for our data, like a numeric or normal. See, it is dependent on the data only. Okay, means for example, I am looking for the numeric values as an output, and my data is having the abnormal information or uh, other information like float information. So in that case, I will just convert that information into numerical formats because I want the output in the numerical formats. If I want to get the output in the nominal format, so I will convert numeric to nominal. So it is dependent on our objective, what type of objective you want to search from the data, what type of output you want to gain through the data. So according to the application and according to the data, you can apply the methods. Any other questions? So might be here some questions are there. If question is there, you can put in the WhatsApp group also. So we'll try to solve it. Okay, so for this moment, we will take a break for 5 minutes, and then we will go for the next algorithm, next methodology of this second session, that is a selection of attributes. This is also one of the important topic for this particular session. Okay, so we will stop for some time. We will wait. We will join after 5 minutes, and then we will continue with the session. Okay, so you can take a break also for 5 10 minutes, and then we can join. Okay, welcome back again. The new topic, that is a selection of attributes. Which attribute I supposed to select? According to the attributes, according to the information, we can select the attributes. Okay, and that particular attribute we can give to the machine learning model, classification model. Okay, so here I will show you how to do it. Am I audible? Am I audible? Can anyone let me know?
Yes, sir. Yes, sir. You are
Okay,
quite audible.
thank you. Now, selecting attributes are the important parameter for developing the machine learning model. Okay, so here let's consider one more type of data, or we will use, let's consider this data, iris data, or yeah, the data which is having more attributes, so we can select that one. Open that. Only 5 attributes are there. So in this case, I will try to open diabetic database. Okay. So here 9 attributes are there and instances are 768. Fine. According to the instances, according to this information, we will try to select the features from the data. Okay. So feature selection algorithm are saying that whatever features are there, whatever columns are there, columns are nothing but the features as mentioned. So those important columns only we need to select, and then according to that particular selected columns, we can build the machine learning model. Means, for example, in my data, thousands of columns are present, or 100 columns are present. All hundreds columns will not be useful for getting the same output. Okay, whenever we provide the same data with the same output, that will also give us the same answer, for example, and the selected information. Let me check whether I'm audible or not. Yeah. So the selected information is also giving the same output. Okay, means 100 columns were there, 100 features were there, and 100 features were giving the same output, and only 10 features I have selected through the feature selection algorithm or attribute selection algorithms, and those 10 attributes are also giving the same output. So that means only 10 columns, 10 attributes, 10 features can be used, and remaining 90 can be excluded. Okay, so we in this case we can save the time, and we can save the memory of our system also. Fine. So that is why the algorithms of selecting the features are important here. So select attributes, and here you will get the two major options. Okay, attribute evaluator and search method. What type of attribute method you want to find out? So according to that, we can just do the information. We can select the information, and then we can apply the search method. Okay. So for example, here attribute selector I am selecting, and you can see some major attribute selection methods have been given. So those are the some statistical method, pattern recognition based methods are present here in the Weka. So that is why Weka is useful. So first of all, this particular first one, CFS subset evaluation. So this is the particular algorithm which evaluates the worth of a subset of attributes by considering the individual and predictive ability of each feature along with the degree of its redundancy. Okay, so in that case, CFS subset algorithm we can use. Next one is a classifier attribute value. Okay, classifier attribute value. So that is also a suitable case. Classifier attribute value evaluates the worth of attribute by using the use specified classifier. So the classifiers like machine learning classifiers we can use here. Next one is a classifier subset evaluator. Okay, so that is also one of the algorithm. Here also we can provide the training data on the subset of the training data, and we can apply the remaining testing data for applying the feature selection. Correlation attribute evaluator. For example, I want to calculate the weight. So for calculating the weight, height is required. So we can find out based on height what will be the weight of that particular person, right? For example, height is near about 6 feet. So we can predict that weight will be near to 70 to 80 kg, right? So that means these two terms, height and weight, are height and weight are correlated to each other. So likewise, correlation attribute methods are also saying the same thing. Whatever algorithms are there, whatever similar features are there, so those features, are they correlated with each other? If they are correlated with each other, then only select those features for developing your model. So this is very important algorithm for selecting the features. Means based on the similar values, based on the related values, based on the related columns, we can find out our solutions through this particular method. Gain ratio. This is also one of the important which can be used for evaluating the worth of an attribute by measuring the gain ratio with respect to that particular class. Okay, so simple formula is there. So behind these algorithms, mathematical formulas, statistical formulas are written in the Java. As discussed in the last session, this particular platform is developed in the Weka in the Java platform. So there the mathematical code, mathematical algorithm of these algorithms have been written. Okay, so every algorithm works with some mathematics. Even here also you can see the formula is given for gain ratio, which is h of class minus h of class divided by attribute, and whole divided by h of attributes. So that type of formulas are used on the particular algorithm, and then Weka can give the particular output. Principal component. Principal component means from the 100, I want to select only the major. Principal means major components, major features. So in that case, principal component will give only limited values, limited features. From 100, it will give only 3 to 5 features which are suitable. So based on eigenvalues, eigenvectors, it will give the output. Fine, then the relief attribute evaluator, wrapper subset evaluator. So wrapper subset evaluator method is also very famous. So any one of the method, again I am mentioning that as per our data and as per our output, the methods can be changed. Okay, so for example, here I am applying XYZ algorithm. That does not mean that you have to apply the same algorithm. You have to check that in that your data, whatever you are trying to analyze, whether that data is having the similar values or not, whether that algorithm is applicable to that data or not. So we have to find out that firstly, and then the algorithms we can use here. Okay, so in this case, as we have loaded the data of our diabetic patients, now you can see my diabetic information along with near about 700 rows and 9 attributes values are there. You can see numeric, all values are numeric. So that is why pre-processing, I mean filtering is not required here. Okay, because all the information is in the same format. Fine. So on this information directly we can apply the feature selection. Even though manually we can check missing any missing value is there. There is no missing value. You can see here. Here also no missing values. No missing values. So means the data is completely okay. Normalized data is there. So that is why there is no need to apply the filters. So it is dependent on the data which method I supposed to follow there. Attribute selection. So I was talking about the methods again for selecting the features. Features are nothing but the attributes. Okay, some people will say the attributes, someone will say feature, someone will say the objects. Okay, characteristics, or someone will say the columns. So those are the related terms with each other. Don't worry about it. Now, for this data, which algorithm is suitable? We can follow the correlation attribute evaluator also. We can follow the classifier subset evaluator also. We can follow the principal component also. Any algorithm we can apply as per the data. So here I am trying to use classifier subset, third algorithm for selecting the features. So just click on that. Whenever we click on that algorithm, here the second option will give you the search method. Which search method is applicable here? Just click on that. Three search methods are there for searching the data according to the selected algorithm. So best first a search is one of the method, data structure method. I hope you have heard about data structure method. So in data structure, best first method is used for selecting the particular searching for the particular values from the data. So here this best first method is applicable for this classifier subset evaluator. Okay, so right now I am selecting the different algorithm. For example, principal component. Now see, alert message warning has been given by the Weka because searching method, whatever by default given there, that is best first is not applicable to the principal component. Here we have to find out the another option, another search method which is based on the rankers. Here you can see now the automatically the third search method is selected when we select the principal component algorithm. Fine. So point is that here whatever data, whatever algorithm I am trying to select here, the algorithm will give us by default setting. So again I'm trying to apply the same classifier subset, third one. Click here. Now again warning has been given because here search method is ranking method. As per the rank, the method is given here. Okay, that is not applicable to the selected method. Which one is the selected method? Here we have selected the classifier subset evaluator method. So for this method, ranker search algorithm ranker search method is not suitable. That is why Weka has given the warning message. So in this case, just click on OK. Automatically, it will apply the suitable searching method, either greedy stepwise searching method or best first searching method. Okay, so any one of the method we can apply here. Keep as it is best first or greedy stepwise, and then go ahead for the data. Now the algorithms we have selected, algorithm in the sense like a feature selection algorithm, attribute selection algorithm we have selected, and accordingly automatically this search method is also selected here. You can click here also on this particular option. Click here also, and you can apply some classifiers also here. You can see choose classifier. So whatever classifier you want to apply here for selecting the data, as mentioned that classifiers, machine learning algorithms, they can categorize the information according to the given training. Okay, so those algorithms for selecting the features also we can apply here. That is the beauty of Weka. Fine. Means the same data if I want to analyze through the Python code, for example. So in that case, for selecting this particular method, directly I will not get the a list of different classifiers. Right now I have selected this particular classifier option. Okay, and that has given the list of algorithms. So that type of facility is not there in the Python. I mean, I'm talking about the automatic methods. Manually, we can just write some few lines of codes, and then you can apply the same algorithm for your feature selection method also. But here there is no requirement of that. Just click on the suitable algorithm, whatever you want to use, and then you can do it, right? So point is that here classifier also we can apply. So evaluate attribute subset. So this is our feature selection algorithm, right? Classifier subset evaluator. So this algorithm will evaluate the attributes subset on the given training data, and it will give us the output, or it separate hold out testing set. Okay, so I'm selecting by default algorithm is a 0R. I'm selecting the different algorithm here. Some algorithms are there like a tree based algorithm, decision tree algorithms, machine learning models, decision tree based random forest J48. Okay, then M5P, LMT, random forest, random tree. Many more algorithms are there. Hope folding algorithm tree is also there. Then part also, and many more. Even though you can say meta classifier in the sense ensemble learning methods are also there. Select any one of the method. Lazy methods are also there. LWL, K star, IBK, so that is not applicable right now. Navy based algorithm, Bayes theorem based algorithms also we can apply here. So I will select the Navy based algorithm. Okay, means as per the requirement of algorithm, we can select any one of the model here, and according to the model, we will get the output for selected features. Click OK, right? And now, after a selection of these many attributes, these many methods, just go for the next one. Okay, what is the next one? Choose the class here. Which one is the class? Last class. For that purpose, just open your data, and here last class is saying the classification output. Two outputs are there: tested negative, tested positive, whether the person is having diabetic or not, positive person or negative person. So that type of classification we want to find out. So that is why here I will select the class, that is the last column where we are having the classes. Okay, here in this case two classes are there, and after clicking on this you can select attribute selection mode. Again here two methods are there. See how many methods are there. Attribute evaluator is one. Then after selection the attribute evaluator method, here we have selected the machine learning model. Then search method also we have seen, third method. Then here again two attribute selection modes are there. Means with a single click we can get the desired output through the Veka. Use full training set. Yes, whatever training is there required for the Navy base. Where was the Navy base? Here we have selected the Navy base algorithms. So as per the model of Navy base, we can give the full training set. Whatever training is there, whatever values are there in our data. So complete values, complete set of training data we can provide to the algorithm, and then we can get the output. Cross validation. So tenfold cross validation is the standard algorithm we can use here. Randomly, some values from the data can be selected, and according to the selected values, we can get our output. Okay, but our target is to select the important features from the data, not for the applying the classifier algorithm. Okay, so we are here trying to select the features. As mentioned that in my data, in the loaded data, 9 features are there. So from 9, how many features I will select for applying the machine learning model? So for that purpose, we can use the complete training set, and then we can run the algorithm. Okay, here click on the start button, start attribute selection, and see. After clicking on the start, the results are generated here. You can see information. This particular evaluator model we have applied, classifier bias method we have applied here, search algorithm, that is a greedy stepwise search algorithm we have identified here, applied here. The data was Pymar diabetics data we have loaded here. In the data, uh, total 768 rows instances records are there, and total 9 classes, sorry, not classes, attributes are there. Okay, and evaluation mode we have taken that all training set, as mentioned here. You can see use full training set. So that particular evaluation model we have applied here. Okay, and so based on that information, we got some results here. Search method is a greedy stepwise forward, start, no attributes, merit, best, subset, and the values, and classifier of the output. And C, selected output. Only two features have been selected by this algorithm. Out of 9, only 2 features have been selected. Means remaining 6 to 7 attributes, 6 to 7 columns we have excluded from this data, and only 2 columns we can apply now. Fine. So in this case, what we can do? We can just apply. Okay. Just a minute. So in this case, what we can do? See, from the 9 attributes, we have selected only 2 selected attributes, second one and the sixth one. So total 2 attributes we have selected, right? So whatever models we are trying to apply for classification purposes, tomorrow we will see classification, and through the classification, with these only 2 features, what type of output we will get, and whenever we apply all the features, what will be the output? If we are getting the same output, then why to apply the complete data for giving the training to the model, right? So in that case, we can select only few features which are best, which are suitable, which are important, and then accordingly we can save the training time of that model, machine learning model or deep learning model, whatever you are applying for that. And we can save the space of our system also. That is why feature selection is important. Mass and PLAS plus, these 2 features are important according to this method. So I will just click on this one, the second feature, and this one, second and sixth one, है second and sixth one, only 2 features are important. What to do about remaining? Just click on the remaining features, and whenever we click on, just click on that box. Whenever we click on that box, the tick marks will be present there, and then the remove button we can apply here. I will deselect this particular box. Now remove button is a deselected. Okay. Click again, and the button is highlighted. Now we can remove the particular features that is not relevant now, that is not required for model development. So accordingly, we can select the features from the data sets. Okay. So here in our case, only 9 features were there. Now consider you have 100 features, and whenever you apply all 100 features, your model, whatever you are applying, will take too much time to run it, right? So that is why selecting the important major features are very important in a data mining for analyzing the required information. Those selected features will also give you the same output, and all features will also give you the same output. So that is why selecting attributes, selecting features are important. Only one method we have seen here. You can apply the principal component. Okay. So as mentioned, whenever I select principal component algorithm, so search method will be different. Click the method, ranking method will be displayed here. Just click on this GUI. So you will get attribute values. How many maximum attribute numbers you want through the principal component? I want only 5. So by default 5. We can select 2, 3 as per the requirement. Okay, minimum 2, 3 are suitable for this principal component. Minimum you can 2 or 3 we can select, that is suggested, and keep by default setting as it is. There is no need to change anything here because algorithm has taken the correct data. Okay, which algorithm? I have selected the principal component. Sorry, ranker. Okay, number to select ranker. Which number I supposed to select? -1 I have selected. So keep as it is. We will check what will happen and select the class. Okay, because selecting the class is important, and that particular class attribute is a combined output of all the remaining features. So that is why we have selected this one, and the method by default method keep as it is, and just click start. Now see, total 8 attributes were there, and according to the algorithm we have selected all training data set. Attribute ranking method we have applied there. According to the rank, it was given -1 value. That is why whatever minus values are there, so according to that we have obtained the output correlation matrix. Correlation matrix is also one of the algorithm, right? Correlation attribute evaluator. So principal component analysis is also using the correlation matrix. So they, according to that, you can see the eigenvalue values and the selected attributes. Minus values we have selected. Okay, ranking 0.70, 51, 32, 36, 24, and this one. So see, we can see manually only first 5 are important because the sixth one is giving 0.00, not sufficient. Here, the number which we have selected is a -1. That is why it has given that type of output. Okay, or otherwise you will ask that key sir why 0 is considered, because there is no meaning with this 0, because there we have selected -1 and selected attributes out of 8 are 7. But see, these last two are not important, and even though through the eigenvalues also we can say that only 4, 2.08, 1.32, 1.02, only these 3 to 4 are important. Okay, so these 4, and we can use only these 3, and then we can select those only 3 features, and then we can build the machine learning model. Okay, one more method we will try. Gain info, gain ratio. By default it will select the ranker. Now here I am giving the plus, for example, +1. Click OK. Again select the class, start it. Okay, see, +1, only one attribute is selected. Why? Because I have mentioned there plus. I don't want to minus values. So that is why it has selected only one attribute as per the rank. Okay, which one? That is the PLAS. First method is first attribute is selected. We will keep by default setting here, and we will run again. Now see, all values, all attributes have been selected. So that is why ranking is very important. Giving the rank to that algorithm is important. If you are giving the incorrect rank, you will get the wrong output. Okay. One more method, wrapper subset, also will use here, which is similar like a classifier subset evaluator. Click OK. Either you can select greedy stepwise or best first. Ranker will not be applicable for this one. Again, you can select the classifier here also. I will apply the Navy base only. You can apply anyone, but Navy base algorithm is suitable for this data. Okay, here some conditions are there. Whether the persons having low weight, having the diabetic, high weight can be the diabetic patient. Okay, so that is the example. Don't consider exact output through this one. So such type of prediction is required. Such type of information is required, condition is required. That is why I am selecting Navy base. Otherwise, there is no particular use of that Navy base for selecting with this feature selection method. Okay, so as per the data, we can select any one of the algorithm. So click again. Now that has chosen the 4 attributes. Greedy classifier subset has chosen only 2. Greedy stepwise wrapper has chosen only 4. Okay, so now you can think which algorithm is suitable for your data. So we have the output of first algorithm also, we have the output of principal component also, we have the output of gain ratio with plus and minus, and we have the output of a wrapper subset method. Okay, so all these method we can check, evaluate, and then accordingly we can get our output. Fine. So that is the story of today's session. If you have any doubt, you can ask me the questions. Before starting the question answering, I have downloaded one data that I will show you, or you can search in the Google directly. So there also you will get the real-time data sets as discussed in last session. What type of methods we can use. So we can search here Veka data or data sets for Veka. Data sets for the Veka. Just to search through the Google. So first link is very important. I will open that one. Then Veka sample databases. Second one is very important. You can use that one also. Others are also important, but here these two are having the good information. So see, this particular scientist has developed the data sets, even though just now we have added the iris data, right? That data we have loaded, diabetic data also we have loaded, weather data also we have loaded, right? All these data sets have been generated by this particular scientist, and you can see he is a good researcher. I will show you his research history. So you can see he is an active computer scientist, and you can see his citations, whatever research he has done. So he is gaining more recognition for his research, and he has done a very good task in a data mining. Okay, and he has generated this data. Second link, this is very important for us. Here only we will get like we will get the information of the data sets. Okay, so downloading is not possible here. Only information, what type of columns are there, what type of rows are there, only that .csv information is present in this data. Okay, so whatever we have loaded there, so that loaded information can be visualized here also. You can see attribute numbers, mean, standard deviation, from 1 to 0, 0 to 1, number of instances like a diabetic data, and the information about the diabetic data is given here. Okay, so that is why I have shown this particular website. Here you will get the data sets. You can see the sizes are also there. Just click on any one of the link. You will get the setup for downloading the information like Dexter zip file folders, Creading, then Amazon data you will get, then again waveform data, convex data, KDD19 anomaly detection data. So limited sizes are there, and last one is having 200 MB size. So any one of the data we can just select. So it will give us the downloading link. Whenever required, you can download there. I have downloaded this KDD Cup 19 data because that data is having only 9.2 MB size. So and having the good information. So that is why I have selected and downloaded this information. Fine. Now we will see the downloaded information. How can we load it? Just open the file. Okay, where it is downloaded, you have to search your location. Now I am talking about the downloaded information. So this was the by default information for us. I have stored my information into this particular folder drive, D drive. Okay, under this one, data mining. Oh, sorry. So again, just double click on this study material. So there I have selected and see these two data sets are there, training and testing. For example, I am loading the testing data. Just open it and now see how many instances are there. I mean 15,000 rows are there in this data and 231 columns are there, 231 attributes are there. Now here feature selection algorithms are very important. Okay, so those algorithms, uh, whatever we have seen right now, will give you the limited features and it will exclude the all features. From 231, you can just select only 10 or 20 features and remaining 200 features we can exclude for from your further processing. Only 10 or 15, 20 features we can select and then remaining we can exclude. See, variable 1 to 231 variables are there and the last is having classes 1 2 classes are there, minus 1 plus 1. So according to that information we can get our output. So I'm trying to visualize the all the content, so it will take some time. Now this that is all about the today's session. In this session particularly we have uh, seen filtering methods with sample data and attribute methods, selection attribute methods with sample. Now see, the data is visualized. You can see through this visualization, this particular 15 number is not having any information. You can see all none values are there, not a number value. Then that means missing values are there. So this column is not suitable for us. So exclude it. How to exclude? Apply the feature selection. So through the visualization also we can find out such type of columns. Here we have identified this one. Then here also these two are there, 31, 32. Here some limited values are there. Here you can see 43 is also not having any information. So such type of unavoidable information we can exclude from the data. We can clean this information, we can convert this information, we can transfer this information, we can normalize this information, and then we can give for the next processing. Fine. So that is why visualization of data is important. Even though manually also we can check here what type of information you are getting. Yeah, only one value is there, delete it, no problem, right? Missing values are 98%, missing values are there, delete it. Missing values are 97, missing values are there in this particular 182 column, delete it. How to delete? Apply the filtering method and accordingly that filtering method will convert the normalize the data, or as mentioned here you can see remove, apply the remove, it will delete it. Likewise, the methods we can apply. Fine. Now you may ask the questions. That is all. Is there any question? Okay, so just give me a second. I will put the attendance in the chat. I am pasting the attendance link. In the question answering also, I am pasting the attendance link for the today's session. Assignment will also be shared. Whenever I receive assignment from the organizers, I will share there also. Fine. Yeah. Any question?
May I, sir? Am I audible, sir?
Okay. If there is no question, so we'll stop here. Hope so. You have gained some knowledge about this particular session. Yeah, Darpan, you can ask. Yeah, Jasmine.
Sir, I posted in a
Yes,
question answer.
Darpan is saying that can we use a dataset from Kaggle or any other? Yes, Kaggle dataset also we can use it, no problem. But try to check whether the data is having the all values, all correct values developed by the provider. Then you can use Kaggle data also. There is no problem with that. Just a minute, I am
Uh,
sharing the attendance. Where to share? I have shared in the chat box here. Okay.
sir, may I ask one question?
Yes, just Jaimin, you can ask the question.
Sir, am I audible?
Is there any question? I'm not getting your voice, Jaimin. Could you put the message in the chat box? Huh. Apart from visualization, how to select attributes to be removed or kept? Okay. So manually, you can check, you can select one by one, and there you will get the type of the data. There you will get the information about the missing values and unique values. So missing values are more from that selected attributes. Just delete it directly. Either you can directly delete the selected attribute which is having zero values, missing values, or null values. Directly remove that particular attribute, right? So that is also possible case. But why visualization? It will give the complete scenario about all features at a single click. So there is no need to check one by one through the manual methods. There is no need to select one by one columns, right? One by one attributes. So in that case, that visualization graph will give us the scenario about which attribute is missing, which is suitable, which is not suitable. Likewise, we can select it and then we can delete it. Okay. Whether there any question? Okay, thank you. Other questions? Okay, then if there is no questions, we can stop here today. And tomorrow's lecture will again will be very important. So in the tomorrow session, whatever learned features are there, we will give the input according to the selected features to the machine learning models, and then we will try to get some output. Okay. So tomorrow's session will also very important for us. Okay, fine. Thank you for joining the session. Have a good day. Bye bye.